1, 1, 2, 3, 5, 8, 13. The Fibonacci sequence. It's hiding in flowers, shells, and galaxies. Let's see it in action. The rule is beautifully simple. Each number is the sum of the two before it. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. And it just keeps growing. Stack Fibonacci squares side by side. And a perfect spiral emerges. 1 by 1, 2 by 2, 3 by 3, 5 by 5, 8 by 8. Connect them with quarter circles and you get the Fibonacci spiral. Here's the magic. Place each seed at the golden angle. About 137.5 degrees from the last. Watch what happens. No seed blocks another. Every one gets maximum sunlight. Nature solved the packing problem using Fibonacci. Zoom in and count the spirals. You'll find 21 going one way and 34 the other. Both Fibonacci numbers. This isn't a coincidence. It's geometry. Count flower petals in your garden. Lilies have 3. Buttercups 5. Some daisies 8 or 13. Marigolds 21. Almost always a Fibonacci number. Nature prefers these counts because they give optimal packing. The Nautilus shell grows in a logarithmic spiral. Each new chamber is roughly 5 times larger than the last the animal grows. But the shape stays the same. Self-similar at every scale. Fibonacci discovered this sequence in 1202. Studying rabbit populations. Start with one pair. Each mature pair produces one new pair per month. Month 1, 1 pair. Month 2, still 1. Month 3, 2. Then 3, 5, 8, 13. The sequence emerges from simple breeding rules. Here's the deep connection. Divide each Fibonacci number by the one before it. The ratios oscillate, but quickly converge to 1.618. The golden ratio. Phi. Fibonacci and the golden ratio are two faces of the same coin. Zoom out far enough, and you see the same spiral in hurricane arms and entire galaxies. The logarithmic spiral, nature's favorite curve, is intimately tied to the golden ratio. From seeds to stars, Fibonacci connects them all. Fibonacci's sequence. Simple addition creates nature's favorite pattern. Golden angle packing, petal counts, Nautilus chambers, galaxy arms, all connected through one elegant sequence. Thanks for watching. Subscribe for more visual math.